So your boy Chili has a lot of bad ideas for projects. People, they're learning, they go through my video series and they're like, Chili, I'm having fun with the series, but I'm having trouble figuring out, what I should do. I don't have any ideas for projects. And I gotta tell you, man, I got 99 problems, but project ideas ain't one. And the trick is, you think of these ideas like, oh man, I could do this. And then you think about it for 5 seconds and then you say, no, that's stupid. That is a waste of time. Let's not go down that avenue. And most of the time, I'm pretty successful in that policy. But sometimes, the tinkerer inside gets the better of me. And you can see that if you look at the Project Moisture, the project where I had the humidifier, reservoir filling apparatus that I built. Yeah, that was not a good investment of time in terms of, how much time it has saved me versus how much time it took to develop. But, most of the time I'm good at avoiding those. But sometimes I just get this dumb idea and I'm like, nah, I'm going to do it. I know this is dumb. I'm going to do it anyways. And I think I got one of those right now. So this game, Warriors of the Eternal Sun, I had this one when I was a kid. And, I had it for the Genesis. It was one of the few pieces of Genesis cartridges I actually owned. I usually just, rented from Blockbuster, but I own this one, and I must say it is one of the games of all time, as you can see by the score here. But it holds a place near and dear to my heart again because it's one of the few ones I owned, and it was my jam at the time. RPG games with like a little bit of a tactics sort of vibe to them. Made by Westwood Associates, who would later to become Westwood Studios. You might know them from Command and Conquer. So, it's got a bit of a pedigree to it. You won't deny. And I was thinking about it the other day, and I looked up some videos. I saw, people doing a Let's Play of it, gameplay with commentary. And I got into it, and I'm like, maybe I should play this game. And then I thought about it. I probably shouldn't play the game. I got other fish to fry. But I started to, because I was watching, and I could notice, like, it's got, like, bugs in it, right? And like jank to it. And I was thinking, this could be fixed. I looked up to see if there was like a patch. There's no patch. But I was thinking to myself, I could patch this. I could fix her. You know what I'm saying? Like I could debug the cartridge ROM and I could reverse engineer the assembly instructions, figure out what logic they're using, where they go wrong, and fix that shit. And I'm in my head, I'm like, why? Why would you do this, Chili? No one asked for this. But I'm like, yeah, but I could do it, though. I could do it. And like, at this point, I'm like, I'm just going to do it. I'm just going to do that, motherfucker. So that's what we're doing today, apparently. We are going to try to hack a Sega Genesis ROM, reverse engineer it, and maybe fix some issues. I don't know. I've never done this before. Your safety is not guaranteed. I don't know anything about 68K assembly. I don't know what tools you would even use to do something like this. A lot of times in the past, I've thought, I could reverse engineer something, but I'm not going to. And I guess today I'm gonna put my money where my mouth is. I'm gonna see how far I can get in this endeavor. All right. After some research, I have found that MAME can run Genesis games now. And so I downloaded MAME, and I also downloaded Warriors of the Eternal Sun ROM, which, by the way, is probably not super legal since I actually own the damn thing. So yeah, so I found I can run this thing if I open a command line, and let's do CMD, and let's do MAME Genesis cart ROMs gen wotes. And here we go. Yeah, I'm running. We got our Sega. We got our 68K, which is what I expect. That's what I understood it had. It's also got a Z80. I don't know what that's doing in there, but I think that's the chip that like maybe the NES uses, maybe the Game Boy uses that. I don't know. But maybe it's like for sound or something, I would imagine. Although it says sound down here. So I don't know. Whatever. You know what? It doesn't matter. Let's just run it. I mean, I've already run it. I did a test, and it works. All right. So, like, yeah, there's some story stuff going on in here. I like this guy's expressions. some bad shit is going down. He's like, this guy knows something. I don't know. He's sketchy. But anyways, yeah, we get the big suck, SUCC. But okay, so listen to this. Like this is kind of litty, as they say. Like this is a bit of a jam, right? Like the game itself is pretty jank, but like this screen and this music, I think this holds the test of time. But anyways, so here's the game. Yeah. So you can like create a party. These kind of games, they kind of start off like this, right? You choose your character, your roster, and you can re-roll their stats and stuff like that. And that's actually one of the things I want to look into. I want to explore what the stats actually do, because it's quite opaque. And people have suggested that many of them don't do what they're supposed to do and don't do anything at all. So that would be cool to look into for sure. But I think to start off, we'll just use like the default party. I don't know if yeah, so we'll just use the default party here. We'll get started. Blah, blah, blah. So yeah, this is what the overworld looks like. You're just kind of walking around. You're just a guy. Which I like. I like this kind of top-down, you know, like Ultima-esque view, as opposed to like some of the games of this, like the D&D games of this generation on consoles. They had like a first-person view, dungeon crawler kind of thing, but I like this better. This game's weird though, because when you go into a dungeon, you go into first person, but this is like the overworld and the town view. So we'll just mess around here. Now, I want to check out some combat. So what I want to do here is I want to figure out how the calculations for combat work, and the way that I'm gonna do that is like do an action where I attack an enemy and just see what the code looks like. All right, now here's a problem. I don't know how to break into the debugger. I don't know what you do for that. 1 second, I'll be back. All right, so here's the documentation for the MAME debugger, and it says you gotta use the debug command line option to start the program with that. So we were screwed from the beginning there. So let's run this with debug enabled. And interesting. So it's given me, nice. It's giving me this debug window, and if I can bring over the game window from here, it looks like it started in a breakpoint. Interesting. We got some options here. We could run. Yeah, it's running. Okay. And we can see it's like doing something, but it's just like alternating between these two instructions for some reason. I don't know. Anyways, let's get back to the gameplay. All right, so I can see it like going through instructions, and it's doing stuff. It's doing stuff for sure. Like I said, I don't know 68K assembly, so I don't know the mnemonics, but I can take guesses, right? Like there's move, you know, there's and branching, stuff like that. Well, it looks like we got, this is interesting actually. So if you look at this, I think we can press the tilde key to break. It said that in the documentation. Yeah. So I can break here, and we can look at this. We can say interesting. So this thing's got 8 registers. First probably data, and A would be address, I assume. Now Genesis is 16-bit machine, like it says it right here, 16-bit cartridge. It's a 16-bit device, but the registers are actually 32 bits wide, which I find a little interesting. And there's a lot of them, which is cool. Yeah, so we can see this is 32-bit wide, and we can see these instructions. A lot of them have width associated with them. So like move W would, I guess, be move word. So this would be a 16-bit instruction, maybe. And IW, but this one doesn't look like, I don't know, man. I don't see anything besides W also. So I don't know. Can I like step through? What's the stepping button? Step into is F11. So like we could just start stepping. We see an L here. Do we see a B? I would expect B for seems bike. Very unlikely. But I know. I saw a B there somewhere. I saw a B. I saw you there. And then it was gone. It was there and then it was gone. But anyways, so yeah, we can do operations at various byte widths, and so forth. Now here's the thing. So what I want to do, I have an idea, but I have to start the thing. How do I start? Run. So I think I want to like do, I gotta click on this thing. All right. So I want to like do an attack, and at the very instance I do the attack, I want to break and then see if I can find the logic for attacking. You know what I'm saying? Like, obviously an attack is going to have probably an animation associated with it, but there's going to be sound effect, but there's also going to be some calculation of like, do you hit the thing, right? There'll be some dice rolls. Randomization is going to be referring to your stats to determine whether a hit was made or not. And that's what I want to look into. That's what I want to get my grubby fingers on. So like, if I could like do an attack and at that very instant break. So if I like press the button and then break, did that, now if I play again, was it going to do the attack? Did it capture my pressing of the button? Run. Yeah, it did it. But I don't know, like, I don't know how fast it's going to do that. And I think what's going to happen is I'm going to press the button and then I'm going to break. But by the time I've broken, it's already gone through the handling of the press and the logic. And it's now just going to run through the animation to present the results, basically. So I'm already too late. So what I would like to do is like have it hit a breakpoint right at the point where I press the button. But I don't know where that is because I don't know the code. I don't have the source code. I don't know how it handles the gamepad or anything. So I need to find some information on how to set a breakpoint when input happens or something else. I don't know. I'll be back in a second. All right, so in execution debugger commands here, we've got a command called trace, and I think does what I might be able to use this. So what this will do is it'll like output to a text file a history of all the addresses visited until you turn the trace off. So what I can do is I can start a trace, then I can do an action, then I can stop a trace, and then I will have a history of all the things that happened in that period, and then I can examine that and try to figure out at least, you know, like where the button press handling happens. That'll at least give me like something to pull at, something to start with. So let's try this out. So I want to get my character positioned ready for an attack, which I think they already are. Yeah, this should be fine. And then I want to select. Okay, so now I'm ready for an attack. Now I want to break. Now here is where I found you can enter commands in. So if I do trace, and we'll do trace action dot what? Dot text. Yeah. So this should start a trace. Now, if I run the program, it'll start tracing out all the instructions visited, which will be a buttload. So I should do this very quickly. So let me see here. So I do run, then I activate this window, then I do the action, and then I break again. All right, here we go. Run, go, bam. Okay, now break. Oh, it hit. Interesting. I was expecting a miss because that's usually what happens. But anyways, let's continue on just a little bit until we get rid of this, because this is part of stuff that happens during your attack, right? So how do I gotta go run. Okay, I actually wanted it to miss. So interesting. Let's try this again. We are going to break. And let's stop that trace. So let's go trace off. Let's see where that is. So that should be in here. Trace actually, yeah. So it's 47 megabytes of trace. That's too big. That is too big for me to examine. So I need to be faster. Also, I don't want that indicator to show up. So I would like a miss, which shouldn't be too hard because in this game you miss like 99% of the time when you attack. Run. So we're gonna run, and click, press. You hit again. What the hell is this game doing? This never did this to me when I was a kid. It was always missing. Okay, get get bent. Run, click, button. You son of a bitch. You are a total... All right, one more time. You bastard. Here we go. Oh, push the button. Okay, miss. Oh, and then this guy freaking attacked. Ah. I am having a hard time here. Surely it's gonna work this time. Surely it can't fail so many times in a row. Wait, we gotta trace off. Trace action.txt. Okay. Now, finger on the button. Run, click, trace, and then done. Okay. Okay. We did it. We captured that. And now I can trace off. Where's my trace action? Okay, 4 megabytes. That is a lot more reasonable now. All right, so let's take a look at this in a text file, see what we get. All right, so here's what the trace looks like. We got about 170 lines here, most of which seem to be instructions, although there's some other stuff here. It looks like it's actually skipping loops. So it detects when you're in a loop, and it says, yeah, you've been in this loop for... So this is like some kind of a wait. Maybe it's like wait until the next frame or something. Wait until the next... wait until the next refresh. Because it's a very long one. And then it does doing a bunch of stuff. Now, like I said, I can understand probably what some of these are doing. I don't know what A means. But I mean, I can say that this is like a move. It's moving 32-bit D0 to D7, A0 to A7. I don't know. So some of it's, yeah, branch if equals, bleh. Some of it I can understand. Some of it is a mystery to me, but there's no way I'm going to find the needle in the haystack here. I'm trying to figure out, for example, like where it's actually detecting the gamepad input. That's not going to happen. Now, what I can do... So I did a trace here that includes my action when I press the button and then the consequence of that. I can do another trace that's just idling, not doing anything, just waiting. And then I could try to find the difference between those two traces. I can try to find addresses that are visited in the action trace that aren't visited in the idle trace. And that'll maybe show me the addresses, the instructions that have to do with the logic of processing the button input and the action that happens as a consequence. You know what I'm saying? We got a plan of action here. So I need another trace that I'll just take right now. So we'll do trace and we'll do idle. This was my plan from the beginning. This was my design. So we'll do this. Then we'll just, unpause for a wee bit. Then we'll pause it again. Then we'll turn that trace off. Yeah, so we got trace action, trace idle. They're about the same because I took about the same amount of time for them. Not that it matters. All right, you can see here, obviously the shorter one has fewer lines. They both start at this loop, which makes sense if this loop is waiting for a scan line or something like that. What's interesting is it actually ran for the exact same amount of instructions in both of these traces. Also, the loop, it's the same loop, but in this trace, we started at a different instruction than this one. So they look like a different sequence of instructions, but they're exactly the same sequence, right? But anyway, so now I have this. I have all the addresses visited during idling. I have all the addresses visited during handling an action. I want to find the ones that are unique to the action trace and like highlight those. So what I'm going to do is I'm actually going to write I could do this in like probably Python or script or I don't know, but I mean, I'm a C++ guy. C++ is just going to be the fastest for me. So I'll be back after I've written a bit of a little programming to process these text files. All right, I'm back. I did a little dev work. I did a little iteration, and I think I have settled on my final solution. So here is there's basically two phases. First, we read in the idle text, and we build up a set of all the addresses visited during that processing. And after we have that set, then we run over the action trace, and we mark each line depending on whether or not it was in the idle set. So if it's in the idle set, it gets no special marking. But if it wasn't in the idle set, that means that this is unique to the action trace, and so we're going to mark it. And I also mark the beginning of a group of action instructions. I mark the beginning of the group with this @@. It just makes it easier to find groups. And I also keep track of counting, how many idle instructions, how many were action instructions, how many were skipped because it wasn't an instruction line, and how many action groups I have. And I output that information, and I output a text file that is annotated, and it should all just work. I mean, it does work. I tried it already. So here we see, so in the idle trace, there are actually only 698 unique instructions executed over, those 170,000 lines. 3,000 of are skipped because, it was, again, let me show you. Like this kind of thing here. This is what you skip, right? Not instruction lines. Now, in the action trace, I processed 174,000 lines. 5,000 of those were lines of action. The rest were all idle instructions. Some skipped, and there were 103 groups of action instructions in there. So that's all fascinating, but let's actually take a look at the annotated trace. So here we can see, for ones that skipped, I just added this to the front. I can't really see, there's too many instructions in here for me to find the needle in the haystack, the ones that are actually unique to the action sequence. But what we can do is we can search. So if I search for ***, you can see I can find, these are instructions that are unique to the actions. You can even see here, it lights them up in the window here. So I can see, hey, they all happen in the middle of the trace, which makes sense because I started execution, and then after some delay of me switching windows, I pressed the button, and that started the action. And then when the action finished, it went back to the idle. So we can see here, I effectively capture the action trace, and it's all, concentrated in this section. But you can see it doesn't just run in this section. It doesn't just run over action instructions. It also runs over the same instructions that are run over in the idle. So it's mixed up in here. But we can search, we can find in the current document, we can find the next one. This is annoying to try to run through them all. That's why I added this @@ here. So I can just search for sections like these. So, if I scroll up to the top here, find the first instance of these @@s. So here's the first time when it deviates from the idle processing, probably in response to me pressing the button, right? But I can keep searching for new sections, and I can see, here's one little, instruction on its lonesome that changed once we entered the action sequence. And here's a very small sequence that changed in action. And those seem to repeat, actually, quite a few times, probably within some kind of loop. And then here this is another big group of things that are unique to when we're processing an action. So this is interesting. This definitely narrows down the stuff I have to look at for when I'm trying to figure out where the actual game logic exists, where the dice roll happens. But it's not a tiny amount. There's 100 groups, it said there. So maybe 10 or 20 of them are actually, significant groups like this, as opposed to just tiny little babies like this one. So I would imagine, my logic would happen in a group that's of more than just one instruction. You know what I mean? But anyways, so originally what I was trying to do was find out where it's actually processing the keyboard, or not the keyboard, the gamepad input. So this is the very first instance where it deviates from the idle. So that must mean that the trigger for processing the keyboard has got to be up here, right? The gamepad. Now we can look at this. We can see here is the instruction happened right before it deviated. This is a branch. And it's saying branch if equals 5EB0. But it didn't go to 5EB0. It went to the next instruction, C8, right? So that means that it was not equal. So when it's not equal, that means a key was pressed, right? And a button was pressed. So we're ANDing D0 with FF, the byte there. I don't know what I means, but we do a mask basically, and we say if any bit was set in the low byte of D0, then that means a button was pressed. So that implies that D0 is holding the key state, the button state. But I mean, if we look up at these guys here, there's a lot going on with D0. I can't even tell. We're ORing these two. I don't know if the result goes into D0, not D0. So it's being modified quite a bit, probably. Move D0 into A. Swap D0 with what? I don't even understand this instruction. So part of my problem is I don't know 68K assembly, that we'll have to find a reference for that. But, so here we see we're moving, okay, so here, these brackets are parentheses, they usually mean access the memory at this address. So it's moving whatever A0 is pointing into D0 here, but into D1 here. But here's where we do the D0 test. So I'm trying to think here. A0, where do we set A0? That is set here, right? So that would imply maybe this is the address where you get the data for the gamepad. I don't know how gamepad works on the Genesis. I don't know if it's like an interrupt. You got an ISR, or whether it's pulled at a certain frequency. So, one second. So when I searched for this address here, I came across this page, which shows that this is the controller to data. So yeah, this code here is loading that address into A0 and then using that to read. And apparently that's controller 2, which is strange because I don't have two controllers plugged in. But maybe the emulator is using the keyboard as controller 1. I don't know. But nevertheless, this is very interesting here. So you can see we got some information about how to load this, and these details might be pertinent in the future. But right now, it's just nice to know that this is how you load the data. And apparently, it's not doing it via an interrupt. It's just pulling it. So this code is probably run, once every frame or something, polling the status of the gamepad and responding appropriately. What can we derive from this? Well, we know that when we hit this address, we have diverged and we have detected that a button was pressed, since it's doing this AND with FF. So it should be that any button I press on the gamepad should allow me to branch to this address, and then it should handle that. And I don't know, like it's doing something and then it's branching to another, and it's a branch? BSR. I don't know what that means, but it's going to this address here, 5DE2, which is part of the idle loop. So this is actually exactly the same. So it doesn't seem like it's doing the logic immediately when you press the button. It's doing the logic. It's probably going to store that somewhere, either in a register or in some memory. So D0 is holding the key state. We move D0 into D1. Let's just a shift D0. And so I don't know, but it's doing some stuff here, storing in D1. It doesn't seem to store anything in memory. I could be wrong, because I don't think it's storing the state anyway. So it's probably going to do a little processing on what keys are pressed, and then it's going to branch to a routine that handles the key state. Maybe? I don't know. I don't know how this works, and it's going to take some time to figure it out, and probably I'm going to have to learn a little bit more about the assembly language. But what I do know, the thing that I wanted was, I wanted the ability to break at the instant when I pressed a button. And I think if I set a breakpoint here I could do that. So here I see in debug, I got a window here. I can see all my breakpoints. I don't see an option to add a breakpoint. Like I right click, there's nothing in there. All right, but if I look at breakpoint debugger commands, I can see BP set. So that seems to allow me to set a breakpoint. So let's try this out. I'm not sure if this needs special syntax for hex versus decimal, but let's just try putting a hex number in. BP set, and we want to set it to 5EC8. 5EC8. And now we see, okay, breakpoint happened, added to here, so that seems promising. Now, if I run, now, if I press any button, it should break. So let's press the right button. I gotta focus the window. Right. Breaks right here. Let's run again. Let's press the A button. Yep. Breaks here again. So, there we go. All right, so at least I figured out how to break on gamepad input, which might be useful. But also, I learned a little bit about the tools and everything. And I think we're making progress. I don't know. I don't know if this will be the end of a video. I don't know how I'll stitch these things together, but I'm going to take a break right now personally. And I'll think about what the next step should be.